All right, so you've made it this far into the lab. You started investigating distance and gravitational force and how those two things are related. And now we're trying to figure out pulling it all together. So we have some sense of this relationship. When you went in, if you looked at what happened to the distance and what happened to the force, this is the factors. So basically, how did it change? We're looking at when the distance was original, if you started at 1, as soon as we double the distance, it didn't half the force like you might think. It was actually 1/4 of the force, which is interesting. When it was 3 times as far away, it wasn't 1/3, it was actually 1/9 as much. It drops off pretty quickly. 4 times as far away, it was 1/16. And I'll bet you can guess if it's 5 times as far away. Let's see, 1 over 2 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared. You guessed it. This would be 1 over 5 squared, 1/25th of the distance. Why? The very quick version is you're spreading out into 3-dimensional space when you look at this. And the area that gravitation has to affect gets larger. Think the surface area of the sphere that's going out. Area is distance squared. So you have to spread out over a larger and larger area. Area is distance times distance. So you're dividing over and spreading it over a larger area. I have a separate video that will go a little bit deeper to try to make that make conceptual sense to you. But suffice it to say that force is proportional to, gravitational force, I should say, proportional to 1 over distance squared. 1 over the square of the distance. It's called an inverse square law. It's inverse because it's the reciprocal, like 1 over distance squared. Inverse square law. Okay, so what can we do with this? I need to hide this. Now, if I whoosh that over here, we have this relationship, 1 over distance squared. From the last part of thing, the last activity we did, we have, that's much thicker than I thought it would be. We have forces also proportional to both of the masses, right? My face. So it's directly proportional to the masses and then proportional to the inverse of the distance squared. We have both these two relationships we looked at separately. Now we want to combine these relationships and say force is proportional to things that are directly proportional, like the masses, mass 1 and mass 2, and things that are inversely proportional, like the distance squared. So this summarizes the full relationship we just kind of uncovered in parts. Proportional to the masses, inversely proportional to the square of the distance. And that's that part. Okay, so that means if I took 100-kilogram person and 100-kilogram person and put them 1 meter apart and squared that, don't forget to square it, that means they should experience 100 times 100, which is 10,000 newtons of force. No, clearly that's not happening. At least that's not equal yet, right? We said it's proportional to that because we're looking at how things change, but it's not exactly equal. So for this last part, why do they put a constant out front? It's because, well, we chose to measure mass in kilograms. The universe didn't decide that. We chose to measure distance in meters. The universe didn't decide that. And we also chose to measure force in newtons. The universe didn't decide that, right? So the units that we use are dependent on kind of the systems that we've created. So we kind of have to convert to, well, if we want to get a force in newtons and we want to use kilograms and meters, because that's what we're used to doing, I don't want to create all new units for things. I need some constant out front, some gravitational constant that'll just kind of work to convert one to the other, right? It gets that relationship. This is what you want to solve for. So to make this equal, you want to take what we know, mass, 2 of the masses that you used, the distance between them, right? All of that is multiplied by g. That's going to be equal to one of the forces that you already have. So plug in what you know, solve for g. You got this.